Hello friends, we are on now to section 2.4 in Brian Passwater's AP Precalculus materials, and this is a review of some important exponent rules, but then also applying those exponent rules to what it means for when we are translating and shifting, right, transforming exponential functions. We looked at function transformation before, right, shifts and dilations and that sort of thing. So now, how does it work with exponentials? We're going to see. So just some quick review, right? The product property, that if you've got two bases being multiplied, as long as it's the same base, 1 to the m power, 1 to the n power, then that's equal to b to the m plus n. So for example, x to the fifth times x to the third is x to the eighth. Okay, the power property, b to the m, the whole thing to the n power is the same thing as b to the m times n, right? When you've got an exponent inside parentheses, and then that is to another exponent, then you multiply the two. So for example, x to the fifth all to the third power is x to the 15th. And the negative exponent property, that b to the negative n is equal to 1 over b to the n. And so x to the negative 3 is 1 over x third, etc. Here are some examples. It says, determine the horizontal transformations of each of the following exponential functions. Transformations, what are we talking about? Well, what we're saying is, what's going to be happening here to each of these. Remember the transformation rules that we had from earlier, that if the transformation is happening inside of the function, kind of inside of where the x is, then that's a horizontal shift of some kind, and it does the opposite of what it looks like. So for example, 4 to the x plus 2, well, that would be 4 to the x shifted twice to the left, right? Shifted left 2, okay? G to the x equals 2 to the 3x. So this would be 2 to the x, but dilated, or rather compressed by 1/3. H of x is 9 to the x divided by 2. So this is 9 to the x, dilated, like expanded, by a factor of 2. K of x is 5 to the x minus 1. So this is the same as 5 to the x shifted right 1. All right, so that we can do. That makes sense, right? Because we've got all this stuff that's in there with the in the exponent, and we're evaluating it that way. But let's revisit example 1a. So this 4 to the x plus 2. Let's take a look at that. Based on our exponent rules, this would also be f of x equals 4 to the x times 4 squared. Interesting. So this would be the same thing as 16 times 4 to the x. Now, that would actually look like a different shift, right? That would be taking 4 to the x and expanding it by a factor of 16, right? A vertical expansion of a factor of 16, right? So what it seems like then is that every time there is a horizontal translation or a horizontal transformation of some kind, because of what's happening in the exponent, we can simplify, and that is equivalent to some type of vertical transformation. Let's take a look at the graphs to get a better idea of what we're talking about. Okay, so using our Desmos calculator, here is what 4 to the x looks like. Now, let's look at what 4 to the x plus 2 looks like. And now we can see this is what 4 to the x plus 2 looks like. It looks like the whole thing is shifted to the left. But from another perspective, you could also think of it this way, that you've taken all the values there and you've multiplied them by 16. Let's take a look. Notice now in green, that's the function 16 times 4 to the x. And it exactly overlays 4 to the x plus 2. Take a look at the the value for 4x, where 4x equals 0, what do we end up with? 1. That's the red function, right? 4 to the 0 power is 1. So if we shift the whole thing to the left, then we end up with the same thing as 16 times 4 to the x, because then what's 16 times 4 to the x, well, that's just, at 0, that has a value, 4 to the x has a value of 1. We're multiplying it by 16. And then you can see, well, there it is, right? So up at the, where the x value is 0, the function value, the function output, is 16. So because of the shape of these exponential functions, horizontal transformations have equivalent vertical transformations. We see that just in the shape, but we can also prove it mathematically, like the way that we were just doing. And that's all expressed in this kind of idea, right? Every horizontal translation of an exponential function like this is equivalent to a vertical dilation of the exponential function that looks something like this. So for example, f of x equals 2 to the x plus 3. So this would also be 2 to the x times 2 to the third power. 2 to the third power is 8, so this is 8 times 2 to the x. G of x is 3 to the x minus 2. So 3 to the x times 3 to the negative 2. Well, 3 to the negative 2 is 1 over 9, right? And so this is 3 to the x divided by 9. Remember, the negative exponent means that you flip, right? So 3 to the negative 2 is the same as 1 over 3 squared. K to the x equals 4 to the 4 times 3 to the x plus 2. So this is 4 times 3 squared times 3 to the x. So 4 times 9 times 3 to the x. And this is 36 times 3 to the x. Also, the power property shows that every horizontal dilation of an exponential function, right, so every horizontal expansion or contraction, is equivalent to changing the base of an exponential function. So for example, we're just gonna, this is multiple choice, but anytime you're doing multiple choice, I would recommend solving the problem first on your own, and then you look back at what the multiple choice options are. So let's do this one. Y equals 9 to the 2x. So this is the same as 9 squared to the x power. So this is 81 to the x power, right? And so we've changed the base. Where is that? Well, that's this one. The answer is D. And how about this one? Y equals 9 times 4 to the x. Here we're looking for a different form of the function where there is a horizontal dilation, or horizontal expansion or contraction. Okay, so when we take a look at this one, 9 times 4 to the x, well, what are we doing with the 4, right? The 9 is separate. We're not going to get to do anything with that. But the 4 to the x, what's the 4 going to turn into? It could be 2 squared, so it would be like 2 to the 2x. But when we do look at our options for the multiple choice, we see that we have a base of 16. Well, how would we get a base of 16 from the 4? Well, 4 is the square root of 16. So watch what happens. This is 9 times 16 to the 1/2 power to the x power. So this is 9 times 16 to the x over 2. Okay, so this is one of the reasons why I like fractional exponents better than the square root symbol, because it makes all of this, envisioning all of this arithmetic, so much easier. And so the answer turns out to be C. That's it for this lesson. Thanks for watching. Don't forget to like and subscribe.